So there's alphabetic multiplication, in which every alphabet shows an encoded number between 0 to 9. Any two alphabet cannot have same value. So if, for example, A equals 1, then B cannot be equal to the same. Again, considering the problem, we can see in the second column the last three elements shows that A plus B equals A. So we'll make this conclusion our first equation. And similarly, we can see that E plus D equals F. That's our second equation. We can simplify the first equation to find the value of B. That equals 0. And considering again the problem, we can see that D times A equals EA, in which the EA shows a two-digit number, not a multiplication. And similarly, we can see that C times A equals T. That would be our fourth equation. Considering the third equation, simplifying and rearranging, we can see that right hand side ends with the digit 0. So this means that on the left side, either A should be equal to 5 or D minus 1 should be equal to 5. We just let the A equals 5 to reach any conclusion, and if we do so, then we see that the fourth equation becomes C times 5 equals D. But as C is always greater than 1, and this is evident as if C was equal to 1, the fourth equation should be equal to A. But as it is equals to D, so C is always greater than 1. For C, any number that is greater than 1, the left hand side is always a two-digit number. But on the right, there is a one-digit number. So we can conclude that A cannot be equal to 5. This leaves us with the only conclusion that D minus 1 equals 5. This will make the value of D 6. So as value of the D is 6, so the fourth equation says that A times C equals 6. There's only two possibilities for two integers to multiply to give 6. That is either 2 times 3 or 6 times 1. 6 times 1 cannot be true as it will make the two alphabets have same value. So there is only two options for A and C. Either A equals 2 or 3 or either C equals 2 or 3. And to find the specific values of A and C, we again consider the top equation, in which we can see that on the left hand side there is a D minus 1 term that is odd as it is 5, and on the right side there is an even term. An even number should be multiplied to an odd number to give an even number. So we can conclude that A is even. This makes the value of A 2, and then clearly the C equals 3. And we can use the same equation and substitute the values of D and A to find the value of E, that equals 1. And use the second equation, and substituting the values, we see that F equals 7. And that's our solution.